All right, so we are still working on the trig, and we are still in 4-3, and we do have 3 days scheduled for 4-3. We also have 3 different assignments, so it's been broken up a little bit. Now, the pace that I'm going might not match exactly what we had for day 2 and day 3 assignments last year. So if you get to something about periodicity when you're working on day 2 today, then just stop, because we're not going to get to that. We'll get to most of this. We're going to find trigonometric functions of any angle. We're continuing on with that. We've already been doing that. Finding trigonometric functions for the real numbers. This, like I said, we might not get to describe the periodicity of trigonometric functions until tomorrow. And then starting our work on the unit circle, we've actually been doing that without knowing it. We are working on the unit circle. So we were way down here at the bottom of page 6, where we want to start talking about special situations. Not that they aren't all special, but these are in particular are where we have to use the coordinate trigonometry. We don't have any choice. So it could be that over the last 3 days you didn't spend a lot of time thinking about how we have to have sine as y over r, cosine as x over r, and tangent as y over x. But for these angles, we have to do that because we can't form a reference triangle. Hey, Logan, you're the third seat right back there. So angles whose terminal sides lie along one of those coordinate axes, those are called quadrantals. And again, in particular, we have to use coordinate trig for these because we can't form a reference triangle with the closest x-axis because they're either on the x-axis or they're on the y-axis. So that makes it impossible. For these angles, we cannot produce that reference triangle. But this is the good part. It is really easy to pick a point P along one of those axes. And in fact, it doesn't matter which of the points we pick, but of course we want to pick the easiest one, the nicest one to work with, and that's what we're going to do. So example 6 says, let's start thinking a little differently here. Evaluating the trig functions of quadrantal angles. Find each of the following if it exists, because we will find that quadrantal angles, sometimes we have to put undefined, because we're dividing by 0, and we know we can't do that. So if the value is undefined, write undefined. Well, let's get a look at it first. So this one says, let's figure out what the sine of negative 270 degrees is. And as always, we're drawing that, or at the very least thinking of it in our noggin where it's going to be. So this would be our 90, 180, and 270 with the terminal side on the positive y-axis up there. And we show the arc again to show that we know that this would be going clockwise because it was negative. Now, they just got done saying, pick a point somewhere on there, because that's what coordinate trig does. And because we're supposed to start thinking about the unit circle, we should also say, well, it should be small, it should be nice, easy to work with. You know what? I think I'm going to pick 0, 1. I think that would be really nice. And the unit circle, in fact, has a radius of 1. So if we were to draw a circle that had 0, 1 as one of its points, we would have the unit circle on there. And now I think about sine, and I remember, okay, sine is y over r. That's our coordinate trig. Well, given that I just drew this at 0, 1, the radius would be the circle from the center, and that means it has a radius of 1, which makes this even better. So now I know that x is 0, y is 1, and that r is 1. And I know that the sine of whatever angle I'm looking at is y over r. Well, this one was the sine of negative 270 degrees. And when I know that, I have to write that. I can't stick with theta. I know that's what I need. And since it's y over r, well, y was 1 and r is 1. Not too bad. No, like I said, that's this is definitely quadrantal. You have to think a little bit differently. And I definitely talked through baby steps on this one. It'll go much faster as you start seeing more of these. So for B, tangent of 3 pi. And we remember that 1 pi takes us all the way across, 180 degrees. This one is a positive angle, so we'll go counterclockwise. 1 pi, 2 pi, 3 pi. So now we're on the negative y-axis. But again, if I get to choose where things are going, I'm going to choose negative 1, 0. And again, that forces my radius to be 1, using that unit circle thinking. And tangent of theta is y over x. But in this case, we know it's tangent of 3 pi. And we just have to figure out what y is and what x is. Well, y is 0. X is negative 1, y is 0, and r is 1. So we're going to put 0 over 1, which is this 0. Having a 0 in the numerator is fine. It's 0. It's the denominator that we have to worry about. So, like I said, the biggest part of this for everybody is going to be whether or not you memorize y over r, x over r, y over x for the primary 3 trig functions, or you start drawing some of these so that you can remember, because on, what was the last day we were here? Wednesday. I had said if you forget, just draw something. Draw a triangle in first quadrant, and then you'll really quickly be able to figure out the x, y, and r pieces and how they all come together. 11 pi over 2. That is definitely not how we're going to think about this one as we go to put it on our drawing. So can somebody help me out? How should we think of 11 pi over 2? And then you go a step further and you say, okay, mixed number. That's 5.5. So 5.5 pi. 1, 2, 3, 4, 5.5. Negative y-axis down there. What nice point should we pick? On? Yeah, sticking with that thinking of the unit circle. So that means my x is 0, y is negative 1, but if we constantly use the unit circle, r will always be 1. Now, secant. Oh, here's a good question after way too many days off for you guys. Which one do we flip? Which primary trig function do we flip to get secant? Cosine. So then you think, okay, y over r, x over r. Oh, I'm going to have to flip that one. That's going to be r over x. So r over x would be for secant of theta. But again, we know what this one is. It's secant of 11 pi over 2. And if it's r over x, well, r is 1. I mean, that's why we're picking numbers that have a 0 and a 1 in them. So r is 1, but x was 0. And now we see why we were given that choice of undefined. Because we can't divide by 0. We hate to say we can't do stuff in math, but you can't divide something into 0 parts. It doesn't make any sense. So we have to put undefined on that. And that is how we do the quadrantals. Now, pretty obviously, there are many more of these because you can do all 6 trig functions for the 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then all the negatives that go on there. But you're going to see some repetition. So, how you feeling about those? Quadrantals? Looking pretty good? Okay, so if you can pick stuff with 0 and 1, things are going to go well. Now, a topic worth memorizing. I don't like memorizing. I never recommend it, but this is one of those things that makes it go much faster if you can memorize it. That's going to be the signs of those 3 primary trig functions in each quadrant. You may have noticed that we always talk sine, cosine, and tangent, always in that order. And we do that on purpose because it makes things easier if you do have to memorize. So what happens is in quadrant 1, everything is positive, so plus, plus, plus. In quadrant 2, plus, minus, minus. Now again, since I'm not a memorizer, I want you to see something here. Do you see how if we flipped this over the x-axis, reflected it over the x-axis, we would get this one? Yeah. So I like that. Plus, minus, minus becomes minus, minus, plus. I'm a really visual person, so that helps a lot. I'm hoping that's not going to be the glare spot for everybody on Google Meet there. So we've got plus, minus, minus, that you flip it over the x-axis, minus, minus, plus. And then to me, this just makes sense in the 4th quadrant that we'd have minus, plus, minus. Again, you forget it, you could do a little sketch. And you'll be able to figure your way out with SOHCAHTOA. You'll be able to do that. But if you want speed, which is one of the things we do want to go towards, you want to think plus, 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 minus, 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 plus, minus, plus, minus. Just kind of get those into your head. It'll definitely, you're going to do it by accident. You're not going to be able to help it, you know. You'll look it up a few times and eventually it'll just stick. That's how our brain works. Fantastic little machine. Anybody need more time to write those down? Alrighty. So now, trig is like a math puzzle. You're trying to put all the things together that you know to find the things that are missing. And we've got find cosine of theta and tangent of theta by using the given information to construct a reference triangle. And the overall name of this one is using one trig ratio to find the others. Now, we're not necessarily going to find all 6, but they said, we're giving you one. Now, find 2 of them for us. Figure out where those are at. And we definitely start with a drawing. And the first information I notice is sine is positive, because this is a positive 3/7. But look at that. Tangent is supposed to be negative. They're trying to tell me what quadrant I should look for this. So I quickly do my plus, 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 minus, 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 plus, minus, plus, minus, to start myself on the right track. Now, sine has to be a positive 3/7. That's either first or second quadrant. But tangent has to be negative. That tells me it has to be in second quadrant. So that's my little theta right there. Again, not drawn to scale or anything. It's just a sketch to help me figure out what's going on. And then I remember sine. Sine is always opposite over hypotenuse. So opposite must be a 3. Hypotenuse must be a 7. In order to tell them what cosine is, I'm going to need adjacent. So we have a little formula we have to use for that. What's that formula? Yeah, Pythagorean theorem. A squared plus b squared equals c squared. So I'll do 3 squared plus b squared equals 7 squared. And we'll be able to figure out what we should use for that missing side length. 9 plus b squared equals 49. B squared equals 40. B is the square root of 40. But we finally have one here that we can do a little bit of simplifying on, because this can be separated into the square root of 4 and the square root of 10. So we'll get 2 square roots of 10. Now here's the part where students miss, and a really important piece. Happens all the time. Did we draw that in first quadrant? Then everything can't be positive. It can't. It's kind of a little pause. You hit your pause button and you go, wait a second, there's something here that's got to change. And that's going to be to the left is a negative 2 square roots of 10. We get going so fast, you know, we're like, oh, we found it. It's in the second quadrant. I know what I need here. and then we just forget to put the negatives on. So now we are supposed to tell them the cosine of theta and the tangent of theta. Again, you just go back to SOHCAHTOA. You've already got this drawn. So adjacent over hypotenuse for cosine. And then for tangent, we need opposite over adjacent. And you realize, oh, I can't leave that. You know, I have to rationalize the denominator. So you multiply by the square root of 10 on the top and the bottom. And notice I went ahead and moved the negative to the numerator. It can be on either the top or the bottom. As long as there's only one, you can't put two negatives on there. That would make it positive. And it's more accepted in mathematics to usually put the negative in the numerator rather than the denominator. Not that either one would be wrong. It's just the way we typically do it. Alrighty, we got another little puzzle over there for B. And if this were a standalone problem, I'd probably do the plus, minus. You know what? It's good for you guys anyway to do that. Let's just do that. If you get used to that, you'll accidentally memorize it. After you do just a few of them, you'll already have it. Alrighty, secant is 3. Well, that's not one of the primary trig functions. Which primary trig function do you flip to get secant? Cosine. They have to have the same sign. So we need somewhere where cosine is going to be positive and sine is going to be positive. There's only one quadrant that does that, right? Which one? Quadrant 1. Secant is 3. You told me we get that from flipping cosine. So that would mean cosine was 1/3. So adjacent over hypotenuse, looking like so. Still going to have to do the Pythagorean theorem. We have to figure out the other one. So we had another one there where we need to simplify. Square root of 8, perfect square of 4 goes into that twice, so 2 square roots of 2. But we're not doing the plus or minus piece because we have to think through that when we put it up here. So now we have the 2 square roots of 2. Uh-oh, there's the blue marker giving me issues again. So I push my pause button and check for negatives. Do I need any negatives? Nah, first quadrant. Yeah, that I think is the reason that we forget to do it when we're not in first quadrant, because we're so used to, hey, first quadrant, everything's positive and nice. Now we need to tell them what cosine is, which we already did as part of this before. We had to flip secant to get that, so that's 1/3. And then tangent of theta, thinking SOHCAHTOA, opposite over adjacent. So 2 square roots of 2 divided by 1 is just going to give us, bless you, 2 square roots of 2. And we've got it. So, as far as puzzles go, I don't think those are incredibly challenging. This next one sometimes throws people for a loop because we just got done talking about quadrantal angles, and then we see C. Cotangent of theta is undefined. Oh. So this has to be 0, 90, 180, 270, maybe even 360 if we go all the way around, but how am I supposed to know that? Well, let's put all the clues together. You getting faster at that already? Yeah, you can't help it. You know, if you do enough of them, it just happens. So cotangent is undefined. Well, pretty obviously, you flip tangent to get cotangent, right? So tangent of theta is y over x. Cotangent of theta is x over y. So that tells me y has to be 0. So there's a part of the puzzle. But the other part is secant is negative. Now we already said secant is what you get when you flip cosine. So let's see. Cosine is negative here and here. Oh, and y has to be 0. Got to be there. It's the only way that's going to happen. So this is our little negative 1, 0. And this time, because it's quadrantal, we have to think about our little formulas. Y over r, x over r, and y over x. So, cosine of theta. Well, x is negative 1. Y is 0. And of course, we pick that so that r will be 1. Again, leading us towards that unit circle. So cosine is x over r, negative 1 over 1. And the other one they wanted was tangent. Tangent is y over x. So our y value was 0. 0 on top is okay. It gives us a 0, just not on the bottom. So the quadrantals take a little more thinking, because you have to use the other information to get yourself started. And you have to think, okay, how did this come out undefined? Where was the 0 at? And put that together with the x's and the y's and the r's and see how all of that works. But we've definitely hit our objectives pretty hard here about, finding them for any real numbers. And we've covered everything now. I mean, before we could cover anything in the quadrants. Now we can also cover anything that's on the axes. That's the unit circle. That's how it gets made up. Trigonometric functions of real numbers. We need to use radians. Going to take some getting used to for a while. What you're going to have to do is like when you learn a language. They say something in the other language and you kind of translate that to English in your head and go, okay, this is what this is. We're going to have to do that for a while with radians. It's just how it is. A lot of schools, especially the baccalaureate programs down in the cities, the international baccalaureate systems, you have a semester-long course of trig. And we talked about that here at Elk River High School years ago when we had our new curriculum. And people said, I just don't think students would double up, because that's what you guys would have to do. You'd have to double up a semester. So you'd have to take a semester of trig alongside another class. And it's a lot of homework. So the reason that we're where we're at, and we're going to find when there's an exploration earlier today, I'm not going to be asking you a lot of questions about things because you don't have a lot of experience with trig. If we did, this would be easier for us to deal with right now, the radians. Hopefully, by the amount of homework you've already done, you're thinking straight across 180 is pi. That should already be in there. As we get going a little faster, you're going to notice a couple other clues that'll help you figure out, okay, this is what I'm talking about in degrees. So our focus here, when we were doing the quadrantals, was picking nice numbers. Those nice numbers come because we're talking about the unit circle. And the unit circle has a radius of 1, and it's centered at the origin. Because if we get to pick where it goes, we're going to pick somewhere nice and easy. And that is definitely easy. So arc length along the unit circle corresponds exactly to radian measure. The unit circle can be used as a kind of number line using what's called a wrapping function. So if we had, the best thing I can think of is a sewing tape measure. It's just basically a fancy piece of tape that has the numbers on it. If we could wrap that around, that's what we would do to talk about the unit circle. We've already talked about how all the way across is 1 pi. So if that's 1 pi, on the unit circle, it should be 3.14 blobity-hoo. You know, that's how it should work. And this little drawing is telling us how the number line would be wrapped onto the unit circle. Note that each number, positive or negative, is wrapped to a point P that lies on the terminal side of an angle of t radians in standard position. So here's our number line. Looks kind of weird seeing it vertical like that. But if we were to wrap that onto the unit circle, we would see our radian measures as we go around. Because r equals 1 in the unit circle. Our earlier calculations, really, really easy. We pick things for a reason in math. We pick them logically, so it'll make the math nicer and easier for us. So here's what happens because we pick r of 1. Notice that this little point on the unit circle is labeled cosine of t, sine of t. Really? So to find an ordered pair anywhere on the unit circle, all we need to know is cosine and sine of t? Absolutely, because of choosing r as 1. Now, why is point P labeled as it is? Well, let's see. Cosine of theta is x over r. Sine of theta is y over r. They made a really big deal about how our choice of r being 1 is a really good idea. Well, if r is 1, then this would be a 1. So cosine of theta will be x. And if r is 1 down here, sine of theta will be y. So for any ordered pair on the unit circle, we can use the cosine of t and the sine of t to figure out what we have. Now, that one is easy to remember. If you remember, ordered pairs always come in alphabetical order. We've always talked about them as x and y, and that's alphabetical order. C comes before s, so alphabetical order again, cosine and sine. When the trigonometric functions are applied to real numbers, they're usually called the circular functions. So we get another fancy little label for them there. The circular functions. Now this is the exploration I was talking about before. If you had already had a semester of trig, I would expect you to be able to help me out huge with this exploration. But you haven't. And so I'm going to be basically telling you things about the unit circle. But we're going to pick up on a lot of these things and understand them more once we start graphing our trig functions. That's when we're really going to understand all of this. So, exploring the unit circle, like it says, works good as a group. We're not going to be able to do that because you haven't seen a lot of trig in the past. And it says to base your exploration and your explanations on the unit circle, which you've just been introduced to, so that would be hard to do. Remember that negative t wraps the same distance as t, but in the opposite direction. So number 1 says, for any t, the value of cosine of t lies between negative 1 and 1 inclusive. R equals 1, and the cosine of t has to be less than 1. So, cosine of t will be between negative 1 and 1. And for number 2, same thinking here. For any t, the value of sine of t lies between negative 1 and 1 inclusive, because r is 1, and sine of t is less than 1. Sine of t will be between negative 1 and 1. Now, we'd already talked before about how cosine and sine would always be a number, a fraction, a decimal between 0 and 1, and that's because it's opposite or adjacent divided by hypotenuse. And hypotenuse is always the longest side, so that will always produce a fraction or a decimal between 0 and 1. 3 says the values of cosine of t and cosine of negative t are always equal to each other. And recall that this is a check for an even function. So this makes a little bit more sense if we look at the graphs and we see that the cosine of pi over 2 and the cosine of negative pi over 2 both land at 0. And making that connection is probably a little better for us right now than our limited knowledge of the unit circle. So to explain that in terms of the unit circle, we would say they are wrapped to the same points above and below the x-axis. And for number 4 says the values of sine of t and sine of negative t are always opposites of each other. And that makes sense if we go over here and we look at our sine graph, because here we have pi over 2 and our y value is up there at positive 1. But if you go to negative pi over 2, you see that it's down there at negative 1. So those are opposites. So again, for us, it really is more helpful right at this point to think of what we see with the even and odd, because our experience is limited with the unit circle. So we could say they are wrapped to points above and below the x-axis with y coordinates that are opposites. The values of sine of t and the sine of t plus 2 pi are always equal to each other. Okay, so you've got a point on the unit circle. And now I have to do this backwards, counterclockwise this way for you guys. 2 pi. Oh, it'd be at exactly the same spot. They're coterminal. Of course they're going to land in the same spot. They're coterminal. If they're coterminal, then those trig functions are all going to be the same. And like it says, that's true for all 6 of the trig functions that we have. Now 6 says, what if we change this to just pi? The values of sine of t and sine of t plus pi are always opposites of each other. The same is true for cosine of t and cosine of t plus pi. So now, this point is over here. Let's see how to explain what's going on there. Well, think of it as a diameter that's gone through the center of the unit circle. You're going to intersect at a point that has the opposite sign, and that's what's taking place. So again, how to put that in the space that we have allotted here, best and easiest way. The x is on the opposite end of the x-axis across a diameter. So the x is on the opposite end of the x-axis across a diameter. And this is one of those explorations that from time to time I think this one we should just probably just hack it out of here. But when we learn how to do the graphing, which is in the next section, when you come back to this, it's going to make sense. It's just hard for it to be happening right now. Oh, people are peeking at the clock. I forgot to set my timer. How are we doing? Oh, we got enough time, a little more time here. Alrighty, so the next one says the values of tangent t and tangent t plus pi are always equal to each other, unless they're both undefined. Tangent is unique. So here's tangent, down here. And notice how it just repeats again and again. So that one's a little bit different. And again, how to word this so it doesn't take up the whole page. That's going to be, actually, here's the easy way to do it. Tangent of t equals y over x. Tangent of negative t would equal negative y over negative x. So they would always have exactly the same side. They'll always have the same sign. Number 8, since I scrolled too far. The sum cosine of t squared plus sine of t squared always equals 1. Well, yeah, because we know x squared plus y squared equals r squared. And we just got done saying on the unit circle we're always going to make r equal to 1. So x squared plus y squared equals 1. Makes perfect sense with the radius of 1. And then number 9, challenge. Like I said, you haven't done enough with these to feel like you could do this. Can you discover a similar relationship that's not mentioned in the list of these 8? Well, they didn't talk about any of the secondary trig functions. So you could start making things up for cosecant. Oops, they want to use t. I'm so used to theta. Secant of t and cotangent of t. And the properties that hold for sine will hold for cosecant. The properties that hold for cosine will hold for secant. And then the properties that hold for tangent will hold for cotangent. So you can just make up some of those secondary trig function properties. What this is supposed to lead us to, which it doesn't do a really good job of, is talking about periodicity of functions. And periodicity is, like I said, or I think I'm going to have to cut things off for today. So tomorrow we'll start here, and we'll look a little bit more at, what do these graphs look like, and we'll definitely be getting the unit circle all together starting tomorrow. So for now, for section 4.3 day 2, we have an assignment up there, which again, it's on Schoology. I am still sending out the Schoology updates every day. So the assignment's on there. It's in Schoology in about 8 different places. So tomorrow we'll finish up the objective about periodicity, and we'll definitely really go after that unit circle tomorrow as well, getting a really good understanding of that. But then, I know it's only been 3 sections, it's taken a while, but our first test covers sections 4.1 to 4.3. So tomorrow would be the end of the new material that we have for 4.3. And I wrote it in the back because I knew I would forget. The test will be on Tuesday, February 23rd.